Welcome to the CourseQ YouTube channel. My name is Shahnun, and in this video we are going to discuss about the unsupervised learning algorithms. In my previous two sessions, I have explained about the regression and classification algorithms of supervised learning techniques, right? So today we will discuss about an important unsupervised learning algorithm, which is clustering. Okay, so first of all, what is unsupervised learning algorithms? Where do we apply these type of algorithms? Okay, so unsupervised learning is a type of machine learning algorithm used to draw inferences from data sets consisting of input data without labeled responses. So what do you understand by this? Simply, we can say that unsupervised learning algorithms are applied on the data which has got no output variable to predict. Okay, when your data has no output variable to predict, in that type of data sets, on that type of data sets, you are going to apply unsupervised learning algorithms without labeled responses. This is what is an unknown output variable. Okay, right? So on such type of data sets, you're going to apply unsupervised learning algorithms. Okay, so what are or how many types of unsupervised learning algorithms are there? So we have got many. Basically, these 5 are used in our data science machine learning. Okay, so today we are going to discuss about clustering. Okay, clustering, PCA, association rules, recommender systems, network analytics. Okay, I'm going to discuss each and every one in detail, right? So today we will discuss about clustering. So what is clustering? So by the name clustering, what do you understand? Okay, clustering is nothing but the division of data into groups. Grouping of similar rows together is called as clustering. If you can see here in this example here, what can you understand? You have got different shapes. So all these different shapes will be clustered together. That is what is the job of clustering. So it is used to divide the observations, the rows of the data into meaningful groups to share the common characteristics. So how can we know if the rows are common or not? That is the question now. Okay. So before that, what is the goal of clustering? So the goal of clustering is homogeneous items, similar items should be clustered between the clusters. There should not be any similarity or there should not be any homogeneity. They should be heterogeneous, right? Okay, so the major usage of clustering is it makes the complex data into simpler forms. It divides the complex data into simpler forms. For example, if you have high dimensionality in your data, what is dimensionality here? Nothing but rows into columns, right? Say for suppose you have got 10,000 rows into 50 columns of data set. So how would you work on this data set? First, you would cluster. You would cluster these rows and columns into various groups and then apply various algorithms on each of the cluster and make your task easy, right? So that is what is clustering used for. Okay, so this is what is clustering. Next, so how many types of clustering do we have? We have got 3 types of clustering, guys. First one, hierarchical, non-hierarchical or Kmeans, DBScan, density-based clustering. Okay, so these are the major or broad classifications of clustering. Okay, so what is the first one here? Hierarchical clustering. So what do you mean or what do you understand by the word hierarchical? So hierarchical word is something which comes from a hierarchy, which means it is nothing but the similarity between the records of the data set. So what hierarchy are we talking about? This is nothing but the similarity of the records, similarity of the rows in the data set. For example, if you take this example here, you have got A, B, C, D, E, and F in your data set, 6 different rows in your data set. Now, how would you cluster these different data points? So what hierarchical clustering does is, it will find the distances among each and every data point, and it will pair up the least distance as the first cluster. For example, you got D and E as your least paired distance. So D and E will become your first cluster. Next, another pair you have got which has least distances, B and C, cluster 2. After that, what clustering will do is, now you have got A, B, C, D, E, F. Now from each point to all the remaining clusters or data point, again the distances are calculated. Okay, again whichever has got the least distance, say A, B, C, D, E, F. F has got least distance with D, E, so it will pair up with this cluster. Okay, so like this hierarchical clustering, in hierarchical clustering, the distance at each step are calculated, and finally all the data points are clustered into groups. Now A is left over. Now A will be calculated the distance with the 2 clusters we have, whichever has got the least distance. Suppose A has least distance with BC, A will be clustered with BC. Now, are your 6 points divided into 2 clusters? Yes, they are divided into 2 clusters, right? So this is what is clustering, hierarchical clustering does. Okay, so this algorithm connects objects to form clusters based on their distance. What type of distance metric that does it use? It uses Euclidean distance metric. We know this Euclidean distance, guys. We have learned this in our schooling. Root over x2 minus x1 whole square plus y2 minus y1 whole square. This is what is Euclidean distance formula is, right? Okay, so based on this Euclidean distance metric, the distances are calculated and they are divided into various clusters. Okay, and so to visualize, this is what is the manual calculation that happens at the back end. So how do you understand, based on the algorithm, in the machine learning algorithm, how would you understand how many clusters the data is divided into? Based on a dendrogram. Okay, so hierarchical clustering is visualized using a dendrogram. So dendrogram is a plot between the records or the rows on x-axis and their respective distances. Now say A and B, the distance between A and B is this. Okay, so the respective distances on y-axis and the rows, all the data points on x-axis is what a dendrogram is. Okay, so height of the link is the distance between 2 records, guys. This is the distance between 2 records. Okay, right? So this is how you visualize the dendrogram and you come to a conclusion how many clusters the data is divided into, right? Now if you break the tree here, exactly here, you will get 2 clusters. This is one cluster and this is one cluster. Okay, A, as it is near to this cluster, you can include this in this cluster only, BC cluster only, right? So this is how your hierarchical clustering works, right? Next, moving to the second classification of clustering, which is K-means clustering. Okay, so K-means clustering is a non-hierarchical clustering technique. Okay, so what is the difference, major difference between hierarchical clustering and non-hierarchical clustering? Okay, so in hierarchical clustering, the number of clusters is not decided upfront. Rather, the distances are calculated, and the dendrogram, based on the dendrogram, we come to a conclusion of how many clusters the data is divided into. Dendrogram helps us in cluster division. Okay. So the distance metric that we use in calculating the distances is Euclidean distance. Once the distances are calculated and clusters are divided, you give that as input to dendrogram. The dendrogram gives you number of clusters. Based on the visualization of the dendrogram, you can analyze the number of clusters. This is hierarchical clustering. But in non-hierarchical clustering, what you have to do is you have to decide upfront, you have to decide the number of clusters. That is what is the K value here. Okay, number of clusters has to be decided by you. Here, K-means is an iterative clustering algorithm, guys, that tries to divide the data into K number of distinct clusters. Okay, so if you can see here, you have got 3 different clusters. Okay, until and unless you get 3 different classification of your data, 3 different cluster classification of your data, it keeps on running. It is an iterative algorithm. Okay, it will divide the cluster in such a way that within the cluster the data is similar, and between the clusters the data is dissimilar, right? That is what is our goal of clustering, right? Okay. And the number of clusters can also be determined in K-means by looking at the elbow plot or scree plot. Okay. So in K-means, K value should be predefined, that is known, and we need to keep changing the K value to get the good number of cluster classification, right? So scree plot will help in identifying the optimal number of K values. Okay, so this is the scree plot. Okay, so scree plot, in this plot, wherever you find a sudden bend, see, this is okay, here you are finding something different. This is one type of bend, and here completely the bend is changing, which means this is the point which is your optimal K value. K is equals to 2. 2 cluster division is what is your optimal K value, and the number of clusters to be divided. Okay, so this bend is considered to be the optimal cutoff K value, right? Okay, so this is how you work on K-means clustering. Okay, guys. Next, the third broad classification of clustering is DBScan, density-based spatial clustering application with noise. So what is this noise term here? Okay, so DBScan is an algorithm which will recognize noise. Noise is nothing but the outliers, guys. Outliers in your data which are not necessary in your classification. These are outliers. Okay, this is one cluster, this is one cluster, this is a cluster. So what about these points? They are not coming into any of these clusters here, right? So these are nothing but the noise or the outliers of your data. Okay, and one more thing you can observe here is shapes of clusters. Did you find these kind of shapes in hierarchical and K-means clustering? No, right? Okay, so that is the major difference between DBScan and the remaining 2 clustering techniques. Okay, so what DBScan is used for is the shaped clusters like oval, linear, okay, different types of shapes. These can be analyzed using DBScan. DBScan clearly identifies the shaped clusters and throws out the noise if there is any. Okay, So whereas these shaped clusters cannot be dealt with k-means or hierarchical, they will not be able to identify the shaped clusters here. They will just make these type of clusters. Okay. Whenever it comes to a shape, you have to understand that that is a DBScan algorithm that you have to use on that clusters. Okay. Okay. So to remove these type of noise from your data, you are going to include two new parameters in DBScan called as minimum points and epsilon. Okay, so we need to give these parameters to the algorithm, and the algorithm tries to remove the noise based on these two parameters. So what is epsilon? Okay, epsilon is the radius that is considered around a data point. Say this is your data point, this is the radius, this is epsilon. Around this data point X, within this epsilon radius, how many minimum points do you have? Okay, so we need to check the density in which the data points are placed in the cluster. Okay, so this is how your DBScan works, and this is how your cluster division in DBScan works. Right, guys? Okay, so this is all about the clustering technique in detail. Okay, so in my next video, I am going to explain about PCA and association rules. Right, guys? If you like the video, please do subscribe to our channel and like the video. Okay.